Hello, welcome to Engineers Mindset. Now let's say we are given this problem. If A equals to I minus 3I plus 2k, and B equal to minus I minus j minus k, and C equal to 2I plus 6j plus 9k. Question says evaluate the magnitude of A plus C. Okay, so let's start with question I. Okay. Question I says evaluate magnitude of A plus C. So the first thing to do is to obtain A plus C. Okay? So we have A plus C equal to the vectors of A give us I minus 3j plus 2k, okay, plus C. C give us 2I plus 6j and plus 9k. Okay, so if we have that, A plus C is actually, remember I said you cannot add vectors unless they are going in the same direction. So only I can add with I. So I'll have I plus 2I, okay, plus I have minus 3j plus 6j, and then I have plus 2k plus 9k. So A plus C is now equal to I plus I is plus 3I minus 3 plus 6j will give us plus 3j. Okay? This will give us plus 3j because minus 3 plus 6 is plus 3. Okay, then I have 2k plus 9k, and that's about 11k. Now the question says to find the magnitude of A plus C. So for obtain A plus C, we now obtain magnitude of A plus C. Okay, so to obtain magnitude, simply take the square root of the square of the individual component that makes up the vectors. So we have square of 3. This is actually 3 squared, plus we have square of 3 as well, plus 3 squared plus 11 squared. Okay, so you have this. So magnitude of A plus C is now equal to the square root. 3 squared is 9, plus 3 squared is also 9, plus 11 squared should be 121. Please confirm 11 squared for me. 11 squared should be 121.
Yes.
Okay, so we have 1, 2, 1. So magnitude of A plus C is equal to the square root of 9 plus 9 is 18 plus 121. This is 139. Square root of 139. What's the value?
11.789826.
It's 11.7. We call it 11.80. So that's the magnitude of vectors A plus C. The next question says we should find the magnitude of C multiplied by magnitude of 2B. Okay? So I will find magnitude of C multiplied by magnitude of 2B. Okay, so let's find magnitude of C first. Okay, this is equal to vector C. First of all, let's pick out vector C. Vector C is equal to 2I plus 6j plus 9k. So we have 2I plus 6j plus 9k. So magnitude of C is simply square root of 2 squared plus 6 squared plus 9 squared. Okay. Magnitude of vector C is now equal to square of 2 is 4, plus square of 6 is 36, plus square of 9 is 81. So magnitude of C is equal to 4 plus 36 is 40, plus 81 is 121. So 121, and of course the magnitude of C is simply 11. Okay, because square root of 1 to 1 is 11. Next thing is to find magnitude of 2b. First of all, we bring out vectors b. Vectors b is minus I, minus j, minus k. So we have minus I, minus j, and minus k. So the first thing to do is to obtain, of course, it's a 2b. So we have to find 2b. 2b simply means 2 multiplied by vector of b. So that's minus I, minus j, and minus k. Okay? So 2b is equal to 2 by minus I is minus 2i, 2 by minus j is minus 2j, 2 by minus k is minus 2k. So after this, you now find the magnitude of vectors 2b. That's simply square root of minus 2. Please take note, whenever you're carrying out this analysis, always put this minus on the bracket all square, because the square of a negative sign will always be positive. So you have to put in bracket. Okay, plus minus 2 squared plus minus 2 squared. Okay, so magnitude of 2b will now give us square root minus 2 squared is 4, minus 2 squared is 4, and 4. Okay, square root of magnitude of 2b is now equal to 4 plus 4 is 8 plus 4 is 12. So you have square root of 12. So that magnitude of vector 2b will equal square root of 12 is what?
3.46.
You have 3.46. Okay, so if you obtain this, question is to find the magnitude of the position, the magnitude of c multiplied by the magnitude of 2b. So if you obtain this magnitude of c to be 11, so therefore magnitude of c times magnitude of 2b is now equal to magnitude of c is 11 times magnitude of 2b is 3.46. So you're going to have that answer to the what? 34.6. Okay, check.
11 times.
11 times 3.46.
38.06.
Okay. So you have 38.06, and that happens to be the final answer to that problem. The next problem says we should find the unit magnitude of the unit vectors of A and then magnitude of the unit vectors of B. So A is finally we have magnitude of the unit vectors of A is position or the magnitude of A. Okay, so vectors A is actually I minus 3j plus 2k. So we have I minus 3j plus 2k. So this happens to be the position vector of A. So we'll find the magnitude of the position vector, and that's equal to the square root of, please take note, this is I, simply means it is 1i. So the coefficient of I here is actually 1. So you have 1 squared plus minus 3 squared plus 2 all squared. Okay, this will give us magnitude of A is equal to square root of 1 squared is 1 plus 3 squared is 9 plus 2 squared is 4. So this is equal to square root of 15. So magnitude of A is square root of 15. Square root of 15 is what?
3.7.
3.7. Okay, 3.7. So that's the magnitude of A. Then the unit vector of A, unit vector is into, yeah.
So, 14.
Yeah.
It's 14.
14.
Yes.
Oh, 14.
3.74.
3.75.
3.74.
Okay. Alright, so this 1 plus 9 is 10, and 10 plus 4 is actually 14. So this is square root of 14. And that's about 3.74. So therefore, unit vectors is simply position vector divided by magnitude of position vector, and that's equal to position vector is simply this, which is I minus 3j plus 2k divided by magnitude as obtained as 3.74. Therefore, unit vector of A is now equal to, so I said you can also break this equation down to I divides 3.74 minus 3j divides 3.74 plus 2k divides 3.74. Okay, so it means that the unit vector of A is now 1 over 3.74. So 0.27i. 1 over 3.74 is approximately 0.27i minus 3 over 3.74. 0.80j. Okay, plus 2 divided 3.74. 0.53k. Alright, so the equation says this now represents this unit vectors is actually A all over by A, okay, which is this position vector all over magnitude, that's the unit vectors, and we have the value to be 0.27i minus 0.80j plus 0.53k. Question says you should find the magnitude of that unit vector. Okay, this is what the question is asking us to do. Find the magnitude of the unit vector. So simply take the square root of the individual position vector. So you have 0.27 squared plus minus 0.80 squared plus 0.53 squared. Okay, let's see what we're going to have. So we have unit vector A is now equal to square root of 0.27 squared. 0.07.
29.
Keep it as 0.07 plus 0. That's minus 0.80, right? Yes. So just square 0.80 square. So 0.0.
0.64.
0.64.
Yes.
0.08 we check.
0.
Okay, 0.8.
0.8.
Okay.
0.8.
0.64 plus the last value there, which is 0.53 squared.
0.28.
0.28. Okay, so which means A all over is equal to square root of 0.07 plus 0.64 plus 0.28.
0.99.
0.9. So find the square root for me.
0.9949.
0.99. So that's okay. So that is for A, the magnitude of the unit vector for A. So we're now going to find the magnitude of the unit vector of B. Okay, so we still carry out the same analysis we've done. So for B, first of all, remember the vectors of B, which is minus I, minus J, minus K. The next thing to do is to find the magnitude of the vector B, and that's simply square root of course, it is minus 1 squared. The coefficient of I is 1, so plus minus 1 squared plus minus 1 squared. They all have one coefficient attached at their back. So the magnitude of B will give us square root of minus 1 squared is 1 plus 1 plus 1, which is root 3. What is square root of 3?
1.73.
1.73. Okay, so that's the magnitude of vectors B. So obtain the unit vectors of B, which is actually B, position vector divided by magnitude of vectors B, and this is equal to position vector is minus I minus J minus K divided by unit vectors is 1.73. And I said you can also bring this equation down to minus I divided 1.73 minus J divided 1.73 minus K divided 1.73. Okay, so if you have this, B all over B magnitude will give us, this is actually 1 divided by 1.73. What's the value?
Minus 0.57.
So this is minus 0.58. 58 I minus 0.58 J minus 0.58 K. Okay, minus 0.58 K. So obtain this to be the unit vectors. Then the equation says we should find the magnitude of the unit vectors. Okay. So magnitude is simply square root of 0.58 all squared plus minus 0.58 all squared plus minus 0.58 all squared. Okay, so you're going to have square root of 0.58 squared, 0.34. So the square of negative is always positive. We have 0.34 plus 0.34 plus 0.34. So add those three values for me. Okay. Unit vectors of B magnitude is equal to square root of
1.02.
1.02. So what's the value of the square root?
1.0099.
1.0. So you can keep it at 1.0. So the square root gives us the magnitude of that unit vector gives us 1. But the equation says we should find magnitude of unit vectors of A plus magnitude of unit vectors of B. And that's equal to, we obtain this to be 0.99, which is approximately 1. Okay, 0.99 plus 1.0. So this is actually 1.99. You can also say it's approximately 2. Alright, that's it guys. I will see you in the next video with another wonderful question on vectors. In the meantime, if you are new to the channel, don't forget to subscribe and as well invite your friends for more subscribers. I will see you in the next video. Thanks and cheers.